Now in this video we are going to learn how linked lists are stored in memory. In the array section we have learned that elements of array are stored in memory contiguously, which means that they are next to each other. So here we know the exact location of cells, so to access them becomes easier. So here I'm not going to go to the details of arrays in memory because I have already explained it in detail in our array section. I just remind you how they are located in memory for comparing them with linked lists easily. So we have just remembered that in case of array, elements are located contiguously in memory, so which means that they are next to each other, and this makes the accessibility of the arrays very easier and efficient. Okay, let's see how the linked list is represented in memory. So here we have a linked list in which we have 4 nodes. So the first node is 1 and the second node is 2, which is referenced by 1, and the third node is 4, which is referenced by 2, and the fourth node is 5, which is referenced by 4. So if you look at the memory, how they are located in the memory, these nodes, we can easily see that these nodes are not located contiguously. So here the first node is referenced by head and the last node is referenced by tail. And when we look at the next to the first node, we see that it's empty. So because the second node is located in a different place, we can only access it from the first node by using the reference. So in the first node we have a reference to the second node, from the second node we have reference to the third node, and from the third node we have reference to the fourth node. So here allocation is randomly. So as we create a new node for a linked list, it will be created randomly in memory and linked to available nodes. So as you can see, if we take for example the second node, the cells to these nodes over here is empty. So this means that these nodes over here are not located contiguously. In linked list, each node needs an extra memory space for a pointer is required to link the nodes. So random allocation of elements allow us to insert as many nodes as required because the size of linked list does not need to be specified at the time of declaration. It allows us dynamic resizing at runtime. Because of random location of the elements in the memory, we cannot access any element directly. Due to the fact that we don't know the location of any element, we have to traverse from the first element to find the required element. So for example, if we want to access the third element over here, first we have to go to the first element by using the head reference. So in the head we have reference to the first node. Then from first node we have a reference to the second node, so we have to go from first node to the second node. Then from second node we have reference to the third node, so we can go to the third node by using second node over here. So this means that we cannot directly access this node over here. But in case of array, we always know the location of the elements with its index. For example, in case of array, if we want to access the third element, we know that the index of third element is 2. So by using array name and inside square brackets we put the 2, we can access directly the third element in the memory because they are located contiguously. So that's why we can easily identify the location of cell in case of array. But in case of linked list, we cannot identify the location of the node until we start from the first node and go to that node using the next pointers of the nodes that we have in our memory. So with this video, I have explained how linked lists are located in memory. So hopefully you have understood everything clearly. So I hope by this time you have a solid understanding about the fundamentals of linked lists. Now from the next lecture, we are going to implement our first type of linked list, which is single linked list. So we'll start to create our single linked list, then we will implement some other operations on single linked list.